This illustration is very visual, and so I thought for this one I would do a screencast so that you can see where I'm pointing with the mouse, and hopefully that will make things clearer as we move forward. So the overall objective of this illustration is to get the big picture of power, to understand all the factors that impact power, and to understand it deeply in a conceptual way that maps right on to what we discussed in the last slide. So all of those components are here. This is just a different way of looking at it. So my goal for you is a deep understanding of this. In fact, in an upcoming exam, I'm going to ask you to reproduce this example and talk through some of the details of it. So I recommend when we're learning this to draw it from memory a few times and then explain the details of it to one of your classmates so that it's just very comfortable and easy to talk about power in this way. So basically what we have in this example here is we have two realities. We have life under the alternative hypothesis, or the blue curve on the left, and we have life under the null hypothesis, or the curve on the right that is red. And remember, the alternative hypothesis is that in reality, the intervention works. There is an effect in the population that we're looking at, and we want to be able to detect it. So that's the goal. Remember from the last slide, the goal is that there is an effect in reality, and we detect it. Recall that reality is something only God has access to. We don't have access to that reality. And so, but again, I think for learning purposes, the hypothetical is extremely important. So you at least know what could be going on in your data once you've collected and analyzed it. So for this illustration, I will use the example of a stress intervention technique. So in an organization or with your clients that you're counseling, you're going to implement some kind of technique for them that you hope will help their stress levels. And so for this example, reduced stress levels are what we're going for. We don't want to increase them. So take note of this example here that the alternative hypothesis is to the left of the null. That means we're reducing our DV of interest, in this case stress. If we had an intervention where we want to increase our DV, like we want to increase happiness, increase well-being, increase coping, these two curves would be switched. So we would have the blue curve going to the right, and we would have the red curve on the left, because we hope our intervention will increase the DV. So take note of that, and I highly suggest drawing it both ways with the proper components of it properly labeled so that you can understand it very well, the illustration. On the x-axis, we have our decision point, so we have set our alpha at a certain level. As you can see, the alpha is the red area with the white stripes. And remember, alpha is the probability of rejecting the null hypothesis when the null hypothesis is true. So it's an incorrect inference. It's type 1 error from the last slide. And something I just want to remind you of is to keep talking about type 1 and type 2 error with the precise terminology. So remember, type 1 error is the probability of rejecting the null hypothesis when it is indeed true. So it is an incorrect inference. By contrast, statistical power is the probability of rejecting the null hypothesis when it is indeed false. So just practice speaking about these concepts in those ways. All right, so again, we have our two realities, and then we have our decisions, and we want to make correct inferences. That's the whole goal. So let's talk about the different components. So again, on the x-axis, we have everything to the left of that alpha is we're going to reject the null hypothesis, and we can either be correct or incorrect about that. The correct part is the blue part, the stat power 1 minus beta. And then the the incorrect part is the alpha, of course. And then everything to the right of that alpha, we're going to fail to reject the null. And so the correct part is going to be the red. It's depicted as the solid red. And then the incorrect part is the blue with the white lines. And that's type 2 error. And again, that's the probability of failing to reject the null hypothesis when is indeed false. Okay, so type 2 error is indicated by beta. And again, what we have there is we're living under the reality that the intervention works, but we're in the decision realm of failing to reject. As you can see, that's to the right of that line. And so this line here, I'll point it to it for you. So everything to this side we're failing to reject, and so that blue area is where we're incorrect, and this whole red area is where we're correct. So that's a good thing. It doesn't look like type 2 is very large compared to this area here. 1 minus alpha, remember that is correctly failing to reject the null when the null is indeed the case. And so remember from the last slide, that was the case where we go back to the theoretical drawing board because our theory was wrong. It's a correct inference, but it just means that it was something we didn't expect, and so we'll just have to do a follow-on study. Maybe for our stress intervention, we needed to do a couple of things differently in order to see the effect. I don't know. That's something you would think about for your own data. Okay, remember everything to this over here. So we set our alpha at this certain level. This is arbitrary. You set it yourself. Remember, Guinness and Hardin say that you're in charge of that, and if you want to increase alpha, which I'll talk about in a second, you can do that. You can move it over to here, make it larger, and that means that you're also cutting into your beta, which you're decreasing now, and then you're increasing power, and you're turning this section to the solid blue, and that is a good thing if type 2 error is very costly for you. So we talked about in the last slide. So if you really need to determine whether prejudice is happening in your decision making in your org, then you will want to decrease type 2 and maybe increase and thereby increase type 1 because you believe that type 2 error is more costly than type 1. So that's something that you have to determine completely as the researcher of what you want to do. But notice in your mind's eye, and I wish, interestingly, I wish that I had an animation of these so that we could pull these curves apart and bring them back together. So if you ever see that online somewhere, I have looked and I have not found a good one. But if you do, let me know because it would be such a wonderful teaching aid. As it stands right now, we just kind of have to do this in our mind's eye. And do it on paper as well. So get out a piece of scratch paper and just scribble it up, and so we figure out what's happening here. But as you can see, as we increase alpha, so we're going to move this white line over to the right, we are going to make alpha larger. We're cutting into our type 2, reducing that, and then we're increasing our power. So remember, Guinness and Hardin are there saying we're going to increase alpha, we're increasing power, and visually that's how it happens. So it's kind of cool. So we're taking our decision rule of whether to reject or fail to reject, and we're moving it over. One last thing to note about this whole diagram is the effect size. And the effect size is the distance here depicted by this red double-headed arrow. So these two white lines that bisect the two curves, respective curves here, those are the means of those two curves. And the difference between those means is what we want to assess with our t-test, and the distance represents the effect size in the population. Or, using our example, it depicts the extent to which our intervention decreases stress. So we're moving the stress this way, decreasing it, and this is the extent by which our intervention does that, which is kind of cool. If you move these curves together in your mind's eye, So take these two and squish them together. And as they come together, this effect size will decrease. The distance between these means will decrease, and our intervention will have a small effect on stress, but it's maybe significant. The thing is that your statistical power will decrease as the effect size decreases. So you will need more N to have a sensitive enough test to pick up a small effect size in the population. So when you're thinking about doing a study, that's what's going to go into your decision about your N size. Is do you expect this intervention to have a small but consistent and maybe meaningful effect on stress? Or do you expect it to have a large effect on stress? And if you expect it to have a large effect, you can get away with less N, because you don't need a lot of N to pick up a large difference. But you do need a lot of N to pick up a small difference, a small effect size in the population. So that's a decision you'll want to think about. So take on a piece of paper, pull these distributions apart in your mind's eye, watch what happens to beta, watch what happens to power as you pull them apart, and then press them close together and look at what happens to beta. Beta, and what happens to power. So, so these are the factors that impact power. To summarize, first, the effect size in the population, as depicted by the red arrow here, double-headed arrow. As it increases, we have an increase in power. As it decreases, we have a decrease in power. So holding all else constant, that's what happens. Holding all else constant, increasing your N size, of course, increases power. So that's an easy one. I think we all kind of know that one from previous classes. And then the other thing that affects power is our alpha level, which we have control over, increasing or decreasing that. And the whole point of Guinness and Hardin, I think, is that conventionally we have placed such a value on decreasing type 1 error, right, that that we have neglected this area here, and this area here may be very meaningful. For example, let's say I think they make this argument that a lot of the studies in the literature are underpowered. And a lot of them don't even make it to the literature because of that. And so Guinness has talked about this for years. He's one of these proponents of thinking through both our alpha and our beta rather than just thinking about our alpha. So that's kind of his legacy in the field of business psych, and that's what's coming through in the article that you read or the book chapter for this week. So, so in summary, there are three things that affect power that some we have control over and some we don't. The effect size in the population we really don't have control over typically, so you can think about that as kind of a fixed thing. And remember, that's depicted by the difference in means here between these two realities, the reality in which there is an effect, and then the reality which there isn't an effect in the real world. And so we don't have control over that. We have control over our N, usually, and we also have control over our alpha. So there are things we can do to increase the accuracy of our inferences, which is the big picture goal. As you can see, I put some notes of the things that I'm saying here at the bottom of the slide, so take a look at those at your convenience. And I think that is about it. If you have questions on this, talk with some classmates, talk with the TA, and then I will be happy to talk about this more when we meet together in person.